Okay, let's unpack this. We've got a whole stack of sources here. Articles, research notes, all focusing on AI predictive maintenance for networks. And honestly, digging in, some of the numbers around network downtime, they're pretty eye-watering.
If you really are.
Like, this Uptime Institute stat from 2022 really jumped out. 60% of outages costing over 100 grand.
Right.
And get this, 15% going over $1 million. That's huge.
It's massive. And these aren't just, small technical glitches we're talking about.
No, exactly. The sources point to things like school systems going dark, public services basically stopping, production lines just halting.
Yeah, it takes a tech issue and blows it up into a full-on operational crisis, financial crisis even.
Absolutely. And the sources seem to really hammer home that the old way of doing things, the break-fix model, it basically keeps IT teams stuck in permanent crisis mode, always reacting.
Constantly firefighting, scrambling after the fact when the damage is already done.
Which costs a fortune, as we saw, and leaves zero time for, well, anything proactive. So that's our focus for this deep dive, using all this material you've gathered. AI-powered predictive maintenance for networks.
Right.
Our goal here is really to sift through everything, cut through the noise, and help you understand what this actually is, why it's becoming so vital, especially for tech leaders, how it works under the hood.
And what the key takeaways are from all these different sources we looked at.
Exactly.
And that break-fix model, the pain point, that's really where the material kicks off, and it makes sense why.
Yeah.
Waiting for something to fail before you jump in.
Yeah.
That leads straight to everything you just mentioned. Unexpected downtime, those inflated emergency repair bills.
Oh, yeah, the emergency premiums.
Exactly. Damage to the company's reputation, massive productivity hits, because, well, everything just stops. It's a painful cycle.
A cycle lots of people are probably desperate to escape. Which brings us to the big shift, right? This move towards predictive maintenance using AI and machine learning.
Precisely. That's the fundamental change here. Moving from reacting and fixing to actually preventing.
Yay.
The core idea, laid out pretty clearly in the sources, is using these, smart AI algorithms. They analyze huge amounts of network data to spot the really early warning signs.
Signs of equipment degrading or some issue brewing.
Exactly. Before it causes a total failure.
So catching problems while they're still small, essentially.
That's the goal. It lets you schedule the maintenance work proactively. You do it during a planned window, not in a panic at 3 a.m.
Right. Avoids the chaos.
And that means much less unplanned downtime. You dodge those huge emergency costs, and ultimately you improve the performance and even the lifespan of your network gear.
Makes sense.
And for anyone running large, complex networks these days, being able to forecast potential failures, one source straight up called it becoming essential.
Okay, I get the logic. Prevent, don't just react. It sounds good. But how? How does the AI actually know something's about to go sideways?
Yes.
Let's get into that data process the materials describe. What's the secret sauce?
Well, it really all starts with building a solid data foundation. That's step one. You have to collect really comprehensive data from, well, pretty much everywhere across the network. We're talking IoT sensor data things, measuring temperature, vibration, power levels.
Only physical stuff?
Right. Plus digging into equipment logs, performance metrics like network traffic, latency, error rates, all of that.
And the sources mention something else crucial here.
Oh, yeah. Absolutely critical. Historical maintenance data. That's the AI's textbook, essentially.
So it learns from past problems.
Exactly. It learns what patterns, what sequences of events led up to failures or issues in the past. That's vital training material.
Okay, so you gather this huge ocean of data, current stats, past logs, sensor readings. What happens next? How does the AI make sense of it all?
That's the intelligent analysis part. AI, machine learning algorithms, they're built to sift through these massive data sets way faster and, frankly, often more effectively than a human team could.
Looking for what?
They're looking for subtle patterns, correlations between different metrics, anomalies, things that just don't look right compared to the baseline.
Things a person might miss in all the noise.
Precisely. The sources really highlight AI's ability to detect these subtle indicators that often get lost in the day-to-day flood of network information.
Okay, finding the hidden clues. And that's what leads to the actual prediction.
Yes. That analyzed data feeds into predictive modeling. These models are designed specifically to forecast future events based on the patterns they've found.
So they can estimate things like when something might break.
Exactly. They can estimate the probability of certain issues happening, predict potential failure times, even estimate the remaining useful life of specific components.
Wow.
And the output isn't just a bunch of raw numbers. It's translated into clear alerts, actionable insights.
Like what specifically?
Like, here's the likely issue, here's the piece of equipment affected, and here are the recommended maintenance actions. That's what enables that smart scheduling we talked about earlier.
Yeah. It feels like this wouldn't be a set it and forget it kind of thing, though. It must need to keep learning.
Oh, absolutely.
Yeah.
The material calls it an adaptive learning loop. These AI models aren't static.
Right.
They constantly ingest new data as the network operates and changes. And crucially, they learn from the outcomes. Did the recommended maintenance prevent a failure? Was the prediction accurate?
Ah, feedback.
Exactly. That feedback loop refines the models over time. They get smarter, more accurate. The system continuously improves its ability to see trouble coming.
That continuous improvement aspect sounds really powerful. Okay, let's shift gears slightly. What about the specific technologies making all this happen? The sources mentioned quite a few. What's actually running under the hood?
Well, at the heart of it, you've got the machine learning algorithms themselves. That's the core intelligence.
Okay.
For really complex, unstructured data like raw sensor feeds, deep learning often comes into play. It's good at finding patterns in that kind of messy data.
And for data that changes over time, like performance trends.
Yeah, for that, time series analysis is key. Things like tracking latency spikes or gradually increasing error rates over days or weeks.
So it understands the trend, not just a single snapshot.
Exactly. It helps the AI tell the difference between normal fluctuations and a genuine warning sign developing over time.
And you need the infrastructure to support all this data gathering and processing, right?
Absolutely. The enabling infrastructure is fundamental. You've got IoT sensors, obviously, grabbing data from all over the place.
Right.
Then there's edge computing. The sources mentioned this is important because it lets you do some processing right near the data source on the network edge.
Why is that good?
Faster alerts. Less data has to travel back to a central point, so you can get warnings quicker, which can be critical.
Makes sense. And the cloud.
Cloud computing provides the heavy lifting, the massive scalable storage you need for all that data, and the serious processing power required to train and run these complex AI models. These pieces work together to make sure the data flows reliably and gets analyzed efficiently.
The sources also touched on some more advanced capabilities. Digital twins, what's that about?
Yeah, digital twins are basically virtual copies of your physical network, or maybe just specific critical components.
Simulation?
Kind of. You can use these virtual replicas to run what-if scenarios, simulate potential failures, test out different maintenance strategies, all without touching the live network. It's a safe space to experiment.
Interesting. And generative AI was mentioned.
Yeah, its role is emerging. Things like automatically generating summary reports from the analysis, maybe helping create insights, or even generating synthetic data.
Synthetic data.
Yeah, like fake but realistic failure data to help train the models if you don't have enough real-world examples, which can sometimes be the case for rare failures.
I see. And AI agents.
Those are described as like autonomous software programs. They could continuously monitor specific things, automatically flag problems, maybe even kick off predefined actions based on the AI's findings, potentially without needing a human to intervene immediately.
Okay, that's quite a tech stack working together. So let's pull back to the big picture. Based on the sources, what are the major advantages for an organization that actually implements this? Why is it such a game changer?
Well, the number one benefit, the most direct impact, is just superior network reliability and uptime. That's the headline.
Because you're catching things early.
Exactly. AI foresight lets you prevent disruptions before they happen. You ensure those critical services stay available, which, let's face it, is the baseline expectation now.
Right. Users just expect things to work.
And the sources are really clear on this. It significantly cuts down both how often costly unplanned downtime happens and how long it lasts when it does.
And less downtime must mean serious cost savings.
Oh, absolutely. Significant cost savings. It hits on multiple fronts.
Oh, so.
Well, first, you move away from rigid calendar-based maintenance. You optimize tasks based on the actual condition of the equipment. So no more unnecessary preventative work just because the schedule says so.
Avoids wasted effort.
Right. Then, catching problems early means you avoid those much higher costs of emergency repairs, rush shipping parts, dealing with the fallout.
A panic tax.
Pretty much. Plus, by understanding the real health of components, you might be able to safely extend their operational life, pushing back expensive replacements.
Deferring capital expenditure.
Exactly. And it helps you allocate your resources, smarter your technicians, your spare parts inventory, less guesswork.
Makes sense. Beyond the tech and the money, the sources also pointed to things like better customer satisfaction and smarter decisions overall.
Yeah, definitely. A stable, reliable network directly translates to a better experience for your users or customers. Less frustration, more trust.
That's huge for reputation.
Absolutely. And strategically, these AI systems generate a ton of valuable data, not just for maintenance, but about overall network health, performance trends, potential bottlenecks.
So it informs bigger picture thinking.
Right. This data gives you actionable insights that can feed into strategic decisions. Maybe it highlights areas needing upgrades, informs procurement choices, or helps you refine your entire network strategy based on hard evidence.
Okay, the benefits sound really compelling. If an organization is thinking, all right, this sounds good, how do we actually do this?
Yeah.
What's the practical path? The sources laid out something like an implementation roadmap.
Yeah, they suggest a systematic approach. First step, build that strategic foundation.
Meaning?
Meaning, figure out what your most critical network assets are, which failures would hurt the most. Then, dive into your historical data. Understand where failures have happened before, look for patterns.
Find the weak spots.
Exactly. And then, critically, establish a really robust data collection strategy right from the start. The sources stress this over and over. Data quality, accessibility, integration, security, these are non-negotiable.
Garbage in, garbage out still applies.
Absolutely. Bad data will undermine the whole thing no matter how fancy the AI is. Get the data house in order first.
Okay, data foundation sorted. Then what?
Then you actually build the solution. That means selecting or maybe even developing the right AI models for your specific network and assets.
Tailoring it.
Right. Then you have to train those models using that clean, comprehensive data you've gathered. And you need a clear plan for deployment. Is it going to run in the cloud? On the edge? A mix?
Practical considerations.
Yeah. And how do the alerts and insights actually reach the teams on the ground? How do they get the information they need to act?
Getting those insights to the right people in a way they can actually use sounds pretty crucial.
It is. And that flows into the next phase, operational integration and ongoing optimization.
So making it part of the daily routine.
Exactly. The AI's insights need to plug smoothly into existing workflows, maybe connect with the CMMS, the maintenance management system. But it's not a one-off setup.
The adaptive learning loop again.
Right. You have to continuously monitor how the AI is performing, track your KPIs, measure the ROI you're getting, and you need to retrain the models periodically with fresh data as your network evolves.
And the human element.
Still vital. The sources are very clear on this. The best results come from combining the AI's data-driven predictions with the experience, the context, the intuition of your human maintenance teams. It's a partnership.
That blend of AI insight and human expertise feels right. Your materials also gave some concrete examples, right? Where is this actually being used today?
Yeah, it's definitely out there working. Telecom is a big one. Managing those huge, sprawling networks, cell towers, fiber lines, switching centers.
Makes sense. Lots of points of failure.
Exactly. AI helps them predict component failures, optimize sending technicians out into the field, reduce those emergency callouts that really annoy customers.
And energy and utilities, that seems like a critical area too.
Absolutely. Grid reliability is paramount. They use it for predicting issues with transformers, power lines, even components in wind turbines or solar farms, preventing blackouts, basically, and keeping renewables running efficiently.
Manufacturing came up as well.
Huge use case there. Unplanned downtime on a factory floor. Incredibly expensive.
Kills production.
Totally. So AI monitors machinery, health vibration, temperature, power usage, predicts when a part might fail, lets them schedule repairs during planned breaks. It minimizes that surprise downtime and can even help maintain product quality.
And the sources suggested it's applicable way beyond those few.
Oh yeah. Healthcare is using it for critical medical equipment reliability. Logistics companies for their truck fleets predicting maintenance needs. Big universities for their campus networks and facility systems.
So anywhere equipment failure is a big problem.
Pretty much anywhere reliability is key. Predictive maintenance with AI has a strong value proposition.
It sounds incredibly powerful, but surely it's not always smooth sailing. What are the typical roadblocks or challenges organizations hit when they try to adopt this? The sources mention some potential hurdles.
Yeah, there are definitely challenges. Probably the biggest one mentioned consistently is data management.
Back to the data again.
Always back to the data. The AI success lives or dies based on the quality, the accessibility, the completeness, the security of your data. If your historical records are patchy, inaccurate, or locked away in different silos,
It's hard to train a good model.
extremely difficult.
Yeah.
You need clean, well-organized, comprehensive data. That means robust collection processes, good data governance. It's often a heavy lift up front.
What else? Getting your tech to play nice with old systems? Staff skills?
Yep, system integration is another common challenge. Making a new, sophisticated AI platform talk to your existing, maybe older, network management tools or CMMS systems, that can take significant effort.
Technical hurdles.
And then there's the people side. Do your current teams have the skills to work with these AI-driven insights? You might need training or potentially need to hire people with data science or AI backgrounds. Though the sources did note that user-friendly system interfaces can really help bridge that gap.
And I guess the elephant in the room, the initial cost.
Right. There's definitely an upfront investment. Sensors, software, maybe infrastructure upgrades, the training, it adds up.
So making the business case is key.
Absolutely crucial. The sources really stress focusing on the long-term ROI. You have to clearly show how the savings from reduced downtime, avoided emergency costs, extended equipment life will outweigh that initial spend over time. Articulating that value is critical for getting buy-in.
Looking down the road, the source material suggests this isn't standing still. AI in this area is evolving.
Not at all. It's moving fast. The underlying algorithms themselves are getting better all the time. That means potentially smarter predictions, more accuracy, maybe forecasting further into the future, even getting better at pinpointing the root cause of a potential problem.
And the infrastructure it runs on is changing too.
Definitely. There's a lot of talk about the synergy between AI and things like 5G, the broader IoT ecosystem, and edge computing.
How does that help?
Well, 5G means more bandwidth to potentially get more data from more sensors more quickly. Edge computing, as we touched on, allows more processing near the source for faster, almost real-time analysis and response. That combination enables more agile, more responsive predictive maintenance.
And what about automating the actual maintenance work itself?
Yeah, the sources point to some exciting frontiers there. Things like increasing automation, maybe using AI-guided robots or drones for inspections or even small preventative tasks.
Wow.
Augmented reality or virtual reality could change how technicians diagnose problems or get remote expert help. And those AI agents we mentioned, their role could expand significantly, taking on more autonomous monitoring, optimization, maybe even initiating actions based on complex predictions. It's heading towards a more automated, intelligent network future.
So pulling this all together, the sources offered a kind of final perspective on making this big shift from reactive to predictive, didn't they?
They did.
Yeah.
They really emphasized that it's not just about plugging in new tech. It demands a deep understanding of your own network, its architecture, your business priorities, its specific constraints.
So thyself.
Basically.
Yeah.
And for big organizations today, consistent, reliable network performance. It's not a nice to have, it's table stakes. It's the baseline expectation.
Can't function without it.
Right. And AI-powered predictive maintenance gives teams the tools, the insights they need to actually meet that standard consistently. It empowers them to cut down outages, get costs under control, and make their valuable infrastructure last longer.
And interestingly, the sources specifically mentioned one company, Turnkey Technologies, TTI, as helping organizations navigate this transition.
Yes, that was included in the material. It mentioned TTI helps companies approach this kind of project with more confidence. It listed their foundational services, things like secure remote access, cabling, wireless infrastructure, security systems, as being important groundwork for an effective predictive maintenance strategy.
So they help build the base.
According to the source, yes. And they also bring specific expertise in helping identify where predictive maintenance will yield the best ROI for a particular business, setting up the data flows needed from the network gear, and making sure the AI's output actually translates into practical, actionable improvements for the network team.
Got it.
The source concluded by saying, effectively, if you're looking at using AI predictive maintenance to boost reliability and cut downtime, TTI is positioned to help with that process.
Okay. Wow.